Hey guys, so today we're going to be looking at two problems that were assigned to me. One with the specific topic of acid-base equilibrium and the other one of chemical nomenclature. So the first problem that was assigned to me was if 25 milliliters of 0.5 molar sodium hydroxide neutralizes 35 milliliters of a monoprotic acid, what is the acid's molarity? Let's just start off by saying that to solve this problem, the only acid-base equilibrium theory that you need to know is basically just what a monoprotic acid means and what it means to neutralize. So a monoprotic acid is just an acid with only one hydrogen attached to it. So we can just denote a monoprotic acid as H bonded to some element A, just a general element. And what it means to neutralize is that the amount of moles in the reactants, there's no excess. Both reactants are the limiting reagent. So the amount of moles in the reactants fulfills the molar ratio. So for instance, if for every 1 mole of sodium hydroxide, there's 1 mole of hydrogen A, or whatever, the monoprotic acid, then it's a 1-to-1 mole ratio. And that means that for this reaction to be a neutralization reaction, the amount of moles of sodium hydroxide has to be the same as the amount of moles as the monoprotic acid. So in order for that to happen, we need to use stoichiometry just to ensure that the amount of moles are essentially equal, which is what this molar ratio says that they have to be in reality. So in order to start this off, we just have to see we have to find the amount of moles of sodium hydroxide, which can be easily found from the information given. Again, molarity is just moles over volume. So since we have the volume, we can find the moles of sodium hydroxide. And once we have the moles of sodium hydroxide, we will know the amount of moles of the monoprotic acid, since they have to be equal based on the ratio. So this is a basic process of finding the amount of moles. This is just dimensional analysis, it's for 25 milliliters times 0.5 moles of NaOH over 1,000 milliliters, which is 1 liter. This is a 0.5 molar NaOH that was given to us because it's 0.5 moles over 1 liter. It's moles per liter basically. And then this is just a stoichiometric ratio, and it ends up giving us that there is 0.0125 moles of the monoprotic acid. Okay, so now that we have the amount of moles of monoprotic acid, we can use the volume given to us of the monoprotic acid, which is 35 milliliters. So again, the molar is just moles over the amount of liters that we have, and since we have 35 milliliters of the monoprotic acid, then we have 0.035 liters of the monoprotic acid. So we just divide 0.125 by 0.035. We end up getting that the concentration or molarity of the monoprotic acid is going to be, let this focus, well, even if it doesn't focus, it's 0.36 molar of the monoprotic acid. Okay, so the second question is about chemical nomenclature, and there's 3 types of compounds that I'm going to explain the chemical nomenclature of. The first is a binary compound containing a metal and a nonmetal. So the thing about compounds of metals and nonmetals is that a metal bonded to a nonmetal is usually an ionic compound. There are very, very few exceptions to this rule, but in general, it's just usually an ionic compound that consists of a cation, which is usually the metal. It's the ionic version of the metal, and the anion, which is the ionic version of the nonmetal. So in order to name this, we have a compound that has two elements that are bonded together, so it's going to have 2 names for each element. And the cation has the same name as usual, whatever the metal is. And as for the anion, here I made a mistake. As for the anion, it's just going to be the root of the anion's name, the atom's name. For instance, fluorine has the root of fluor, chlorine has the root chlor, oxygen has the root ox, nitrogen has the root nite, and yeah, you get the idea. You have to know those roots. They just come up and you basically memorize them through practice. And then next to the root, you add the suffix "ide." suffix "ide," which is okay, and the anion is always going to be the nonmetal part of this compound. Here's an example of it, just like so it's NaCl is going to be sodium chloride. So here the cation is just sodium, and then the anion is going to be the root of chlorine, which is chlor, and then we take out the "ene" and we add the suffix "ide," so chloride, sodium chloride. Okay, so now we go into the binary compounds that contain two nonmetals covalently bonded. This is another version of the chemical nomenclature that I'm going to show you. So here we have a nonmetal bonded to a nonmetal. And again with this, no matter what, the second element that it's bonded to, or the last element that it's bonded to, is going to be, it's going to end with the suffix "ide" and it's going to keep its root. However, each nonmetals, each part, are going to have these prefixes before the root. And this just depends on the number of each element in the compound. So these are the prefixes. We have 2-di, 3-tri, 4-tetra, 5-penta, 6-hexa, 7-hepta, 8-octa or octo, 9-enea, and 10-deca. So here's an example of this, just for better clarification. For instance, we have CO2, which we know is carbon dioxide. So there's only one carbon, so we don't really have to worry about the prefix in the first element. But in the second, there's 2 oxygens, so we're going to add the prefix "di" and then oxy, or ox is a root, and then we're going to add the suffix "ide." It's a little more complicated than the ionic compound version. So the last thing that I'm going to explain is just binary acids. This is very step-by-step. So the binary acids consist of 2 words. The first word, again, it's just two compounds put together, so it consists of 2 words. The first word is hydro. Hydro is just going to be the prefix signifying the H that's bonded to the binary acid. And then it's going to consist of the root of the nonmetal element, and it's going to have an "ic" suffix. And the second word is always going to be acid no matter what. So here's an example. HCl is hydrochloric acid, HBr is hydrobromic acid, and HF is hydrofluoric acid. Again, these are the roots, chlor, brom, fluor, and then we have hydro in each one, and then we have the suffix "ic," and then it's always acid for the second word. And that's basically it. Thank you very much. My name is Andres Martinez.